notes. We're kind of moving on to a new, it's very related to what we've been doing, but we're going to do it more graphically than like algebra-wise. So, see how this goes. I'm going to kind of start going through, I put the graph in zones. And that's kind of the equivalent of like your number line when you do like when you do a problem, you find the relative max, relative min, increasing, decreasing, all that stuff. If you end up with a number line, that would kind of show those points. I'm just using that start there. And then we're going to talk about what F looks like in that zone, which F is the original, right? What F prime looks like in that zone, and what F double prime looks like in that zone. And we're going to kind of move through and just talk about what happens to F prime, and F double prime as we go. Alright, so in zone A, so I'm just looking at this part over here, and I don't even need numbers, but I'm looking at this section. There are three things that are true about F of X. Can anybody tell me one? Yeah. Increasing. F of X is increasing. That is true. I'm going to put that in seconds. It's positive. Okay, wait. I'm sorry. Let's back up. How do we know it's increasing? Here's another thing. The word "it" is now banned. Because if I say "it," I don't know what I'm talking about. F prime, or F double prime. So I have to be clear. You have to be clear when you ask questions. But how do I know F is increasing? Okay. Slope is positive, right? So A is positive. How do I know A is positive? Or zone A, the graph is positive. How do I know that? We're above the x-axis, right? Yeah, something might feel like it's your question. Alright, so then what else? There's a third one. Kind of gave it up. Good. So if you notice, I can give you three characteristics there because every level I go down, I can find a new characteristic. And if I'm at my very top level, I can get a characteristic from F, a characteristic that kind of has to do with F prime, and a characteristic that kind of has to do with F double. Well, now if I jump down to F prime is like hard to see, but there's only two things I can say about F prime. So, what is true about the derivative, which represents slope, remember, in zone A? Positive. How do I know the slope is positive in zone A? I'm sorry, how do I know the derivative is positive in zone A? What does derivative represent? Slope. Is the slope positive? Yes. So I know that F prime of X is positive here. These two things, if I get rid of those, are the same. If F is increasing, F prime is positive. That's the exact same statement. Well, there's another statement that is the same as that. This is the hard one. What else do I know about, and we're still in zone A, what else do I know about the derivative? Or the slope? It's decreasing. Good. So the slope is decreasing. You see that as we go? So the slope here is steeper than the slope as I move along. So F prime of X is positive and decreasing. Kind of the same idea with this arrow here. F prime decreasing and F concave down. Same exact statement. F double prime of X has what characteristic? F double prime of X is negative. How do we know that? You can't say the word "it." Yeah, that's it. Yeah. So there's two ways you can say it. You could say because F prime is decreasing or because F is concave down. F double prime is negative. And so these three things are all the exact same statement. These two things are the exact same statement. Another way you can get to this, and some people are able to look at this, like look at the original graph and just kind of do everything from there, and think about the slope level and think about the concavity. Some people are better off graphing it. So if I sketched a graph of the derivative, and I'm not going to do the whole thing, I'm just going to do zone A right now. The derivative here, so the slope. What? Yeah, you have a question?
No.
You're gonna answer me?
No, my answer's
Oh, I got it excited. All right. So what is the slope doing? There's two characteristics about the slope here. It's positive and decreasing. Isn't the slope positive but also getting smaller as we go? So when I go to graph my derivative, I need to have positive values that get smaller as I go. And what should my slope be by the time I get to this line? So what should my y value be by the time I get to that line? It should be 0. So that dotted line is me attempting to draw f prime. So f prime has what two characteristics? We just set down here. It's positive and decreasing. Well, if I graph that, positive and decreasing, looks like this. The big picture here, I'm just trying to connect all of this stuff. Like, ideally, I should be able to tell you, like, basically one of these things in this chart, and you can kind of get to everything else. So you want to try to make connections as much as you can between, okay, this means this, which means this, which means this. That's the goal. This is a big topic. We're going to be doing this for a while. Yeah?
Does it matter if that prime is curved or straight line?
It needs to be curved because your slope is curved. So, like, my slope starts off positive and then it gets... Remember the wiggles? Wiggles is probably a better way to explain it.
Yeah, I feel like since that has one wiggle.
Look at the bigger picture, though. This has 2 wiggles, right? 1, 2.
Right.
So, big picture-wise, my derivative is going to have... So, if you take away from just that little section. Okay. Wait, hold on. Yeah, this isn't drawn very well. It's more like this. And we're going to end up going like this. I think that might have been what screwed you up because I didn't draw it like as well as I could have. So we'll get to that. Okay, and then, again, a lot of people don't do this. Don't need to do it, don't prefer to do it. It's not a need to, it's not like better or worse. But I could also draw the second derivative. What is true about the second derivative in this zone? So now you can do it 2 ways. You can look at the concavity of this. Is this concave up or concave down? Concave down, so what's true about the second derivative? It's negative, right? Or, if I take the slope of f prime, doesn't slope knock me down a level? So if I take the slope of f prime, aren't I taking the derivative of f prime? Slope and derivative are the same idea. So is the slope of f prime positive or negative? It's negative. So is f double prime positive or negative? Negative. So f prime is just down here somewhere. And I don't even know what the shape is necessarily. Well, I mean, I can start getting to it. How many wiggles are in the original? 2. How many wiggles are going to be in the derivative? 1. So how many are going to be in the second derivative? 0. So 0 wiggles is a line, right? So we're going to end up doing this, going through the axis and looking like that. Come back here for a second. Look back. This is a huge piece of what we're doing. So we've learned derivatives, learned integrals. We're starting to get into, okay, how do you go back and forth? How do you look at a graph and integrate it for a derivative? So anytime you want to go down a level, taking the derivative, if you have the equation, you take the derivative. If you have a graph, you take the slope. So if I take the slope of anything, that knocks me down a level. Whether it's from f to f prime to f double. If you integrate, if you want to go up a level, you start taking the area or integrate. We're mostly doing this now, but some of this too. But every time I say find the slope, That's the exact same thing as saying find the derivative. Same thing as going down a level. I mean, make sense what I mean by like up and down a level. Original, down a level, take the slope of the derivative, down one more level, take the slope of the derivative. Alright, let's go to the second part as we switch from zone A to zone B. What exists on the graph? In the original graph, f of x, when I switch from zone A to zone B, what exists there? Right there, relative x. So, f of x is switching from what to what? Positive to negative, increasing to decreasing. Can't give down, can't give up. Like, what do we? Increasing to decreasing. I can't show everything. I'll try to go back and forth, I guess. Make sure you don't say from positive to negative. If you say positive to negative, what you're saying is from above the axis to below the axis. That's not what you want to say. You want to say f prime of x was increasing, and then it was decreasing. Now when I get to the derivative switches from what to what. At that spot, the derivative prior to that was blank, and after that, it's now blank. Positive to negative. Two ways you can look at that. If I look at my original graph, the derivative is the slope. So prior to the relative max is the slope positive or negative. Positive, and after it's negative. Or if you're one of the people that likes to graph the derivative, isn't the derivative above the axis prior to that spot and below the axis after it? So positive to negative. And then f prime of x in that whole A to B zone is always what? That's f prime. F del prime. Second derivative. As we're switching, whether we're in this zone, or switching there in the middle, second derivative is what? Negative. How do we know that? Don't say the word it. F of x is concave down. So f prime of x is negative. Sorry, that's slide down. Alright, let me take questions. I gotta know if there's questions. It's hard for me to tell if you understand or not. This is a hard thing to tell if people understand in general. So I think Quinn gets it. No one else is really saying much, so I don't know what can I do? What can I help with? Go over this again. What the hell are you talking about? Yeah.
So for f of x double prime, it is negative because f of x is concave down?
Yes. So slope moves you down one level, concavity moves you down two levels. Anything else I can help? Do you want to try the next zone, or do you want me to? Me too?
I want to see it.
Okay, that's totally fine. I think that's fair. Alright, let's go to zone B. So, f of x has what three characteristics? So in zone B, f of x, you should be able to three things. You should be able to say something about the original, something about the derivative, something that you get from the derivative, and something that you get from the second derivative. Three characteristics. So what is, someone raise your hand and give me something that is true about f of x in zone B. Didn't raise your hand, but I'm so excited someone said something. Call on someone, please, Jasper. We'll make you guys talk. Mitchell, how do I know? Is he correct?
Yes.
How do you know that?
F of x is above the x.
Perfect. Someone raise your hand and give me another characteristic. Dustin? F of x is decreasing. Call on someone. Jack, is he correct?
Yes.
How do you know that?
Because the slope is going down.
Careful. It's not Slope is negative. See the difference? Like my bank account is negative, and my bank account is decreasing, or you know what I mean? The two different things. So you just want to say it's negative. So what's the third one? Yeah.
I have a question.
Oh.
Why is it not right to say the slope is decreasing?
So now, when you say decreasing, you're talking about that word has slope in it. Like decreasing means it's going down. So you're saying it has a negative slope. Okay? So if you say the slope is sloping down, now you've used slope twice, which puts you at a second derivative. So that's a good question. So decreasing, if I should define decreasing, slope is negative would be a very fair definition, right? You know, if something's going down, is the slope positive or negative? Negative. So now if I say the slope is decreasing, well, I just basically said the slope has a negative slope. And every time you say the word slope, you took a derivative. So how many derivatives did I take in that statement? I took 2, right? Where I really just wanted to say the slope is negative, which is just 1. Does that help? Yeah. It's hard. I'm not saying this is easy. I'm like, oh yeah, I get it. This is totally fine. Like, we're going to practice this for a while. But that's the reason. So there was one more. Did someone start saying this third one? I can't remember. Or Naomi had a question, but I thought she was wrong too. So there's one more. Yeah. What's it? I don't know what you mean. What are you talking about? What's that cuss word you're saying? F of X is concave down. Call it something. Yeah, how do I know that? Bending down. What's another way to say the curve is bending down, or the slope is bending down? Slope is negative. Can be, so this, is that a negative slope? Yeah. Is that a negative slope? Yeah. Is that a negative slope? Yeah. In this one, what's the slope is negative and doing what? Increasing or decreasing? In this one, the slope is negative and decreasing. Right? Agree? In this one, the slope is negative, but increasing. Agree? In this, the slope is negative and just constant. Like it's not increasing or decreasing. Should we write those pieces down? Like make notes on that? Let's do that. Let's go back again. Alright, so let's do this. Negative slope could be that, or that. This slope is negative and decreasing. This slope is negative and increasing. And I'm not going to worry about the line part. That's just not a thing that comes up very often. If the slope is negative and decreasing, what's another word for that? 2 words, actually. Do something. Say it louder. That's concave down. Slope is negative and decreasing. Slope is negative and increasing. What's that? flip all that around with positive slope too, right? So okay. That slope is blank and blank. Positive and increasing, which is summarized as saying that is concave up. That slope is positive and decreasing, which is concave down. Naomi, what's your question? Naomi, what's your question? Can you ask it anyway?
Yes. So what would f of x be for the second one? Like, what would f of x, would it be increasing or decreasing?
F of x here
Yeah.
would be, I don't know if it's positive or negative because I don't have an axis to look at it. So positive or negative would be determined by is this little piece here above or below the axis? I don't know that. Decreasing and then concave up. And this would be, again, I don't know positive or negative, but it'd be decreasing and concave down.
We broke it up into 4 different pieces if it's concave up, concave down, and decreasing or increasing. So I was trying to connect that to this.
Yeah, so what did I say?
Just that second one is being problematic. The other 3 are working. I'm thinking I just wrote it down wrong.
Just this one?
Yeah, and I'm thinking.
So this should be f prime of x is negative and f double prime is positive. Like I wrote them on the board over there, right? That's what you're talking about?
Yeah, and I copied them down. I think I just copied.
What's
So I
that?
have decreasing for this one.
You have the slope is decreasing?
I have f of x decreasing concave up, and then f prime is negative, and then double prime is positive.
Everything you just said is true.
Um,
So, I mean, this is why this is hard, because you get negative, increasing, decreasing. Fill in that word. Like, not out loud. No, I guess I shouldn't worry about out loud too much. Tell me what, think in your brain, what word goes in that box. So I'm doing this graph. So what is true about f of x here? What is f of x doing? Decreasing. So when f of x is decreasing, these two are the same statement. F prime of x is negative, and then in this case, f double prime is positive because I know that we're curving. So I think you did have it written down, right? You're just like not fully pieced together.
Yeah.
This is hard. This is like my favorite thing. So I don't have to do a bunch of work. I can just think out, like write out steps and stuff. Some of you guys, I think, will really like it once you get the hang of it. It's just hard. It's hard at first. All right, let's go back to zone B here. So again, in this piece, and that's what I'm trying to write here, f of x is positive, so we're above the axis. F of x is decreasing because it's got a negative slope. And f of x is concave down because the slope itself is decreasing. So then let's go to the derivative level. F prime of x has what 2 characteristics? So somebody raise your hand and give me something that's true about f prime in zone B. You already went, so I'd like to get someone else, but let me see. Same people. Yeah. F prime of x is negative. Call them. Do you agree? Why? You should agree. Because the slope is negative. So, even if it were doing this, your derivative would still be negative, and that wouldn't be a decreasing slope, right? So the slope is negative. So call it someone else. What in the first, like this is the same as f of x being which one of those? Does that make sense what I'm asking? Yeah. So these two are the same, right? F of x decreasing and f prime of x negative are the same statement. So give me another. You were right. You thought you were wrong with it. Give me another characteristic of f prime. Yeah, Jasper, go ahead.
It's decreasing.
It is decreasing. Call on someone. There are people with their hands up if you want to pick one of them. Josiah, how do I know f prime is decreasing? Good. That is good. That's, yeah, okay, how else? Someone give me another. No, that's good. That's not what I would have said, but that's a very, like, there's two completely equally legitimate statements, and you did the harder one. I think. That's the harder for me, at least. Someone give me Josiah calling someone then. How else do I know? I forgot. How do I know that the...
F prime is decreasing.
Yeah, how do I know f prime is decreasing? And he said concave down, which I guess is a better version of what I would say. How can I tell by looking at the graph without saying the word concave? How do I know the slope is decreasing here without saying the word concave? Yeah, somebody.
The slope is approaching 0.
Doesn't it start at 0? And then, like, get... So this,
Looking at f prime. Or f prime, sorry. F prime approaching 0.
oh, so, okay, so that's basically you saying f prime is decreasing, like going here to 0.
Yeah.
Okay. So that's like the same. Maybe looking for this. We're gonna move on. I think I'm looking for the same answer. Two different ways. So again, we get this like commonality here. Yeah.
I don't know if I just heard you wrong, but were you looking at the graph for f of x when you were doing the f prime of x?
I was.
Oh, okay.
So I can do it two ways. If I want to know about f prime, I can look at f and think about what in my head to get to derivative. Think about the slope of it. Or I can actually do the slope
Okay. That makes sense.
and then look at that. So like either
Okay, because I was just looking at the graph of f prime, and then you were talking about the other one, so I was just confused. I got the same answers.
okay.
But
Okay. F double prime has what characteristics? Anybody? Shout out.
Negative.
Negative. Which is the same as these two, right? F prime decreasing and F concave down. Okay, let's do this last part. This is like a zone switch again, so this will be our second like zone switch that we do. So as we switch from zone B to zone C, so we're right here, on f of x, what is that point called? Point of inflection. We'll put POI. People always think that means person of interest or point of interest or something like that. Point of inflection, so remember the inflection word. So, f of x is, I don't know why it says is there. It should say f of x switches from what to what. So at that point of inflection spot, what does f of x, what's the switch there? What's changing? It is changing from positive to negative, but that doesn't make it a point of inflection necessarily. That's just going above the axis to below, which could, like that happens a lot, you know, it's not a point of inflection.
Concave.
It switches concavity, right? So we switch from this U shape to this N shape. So f of x switches from concave, where we concave up or down prior to that. We were concave down, we're switching to concave up. So now, if you want, I mean, well, I'll get there in a second. Alright, F prime switches from what to what? This is the hardest one, I think. F prime switches what to what? Decreasing, increasing. Good. So your slope here is getting smaller. It's getting more negative. My bank account is shrinking faster. But then, even though it's still decreasing, it starts like kind of leveling off. So it's not decreasing as much anymore. So f prime of x, the slope, switches from decreasing to increasing. Can you see that on the f prime graph? And we graphed f prime, right? Doesn't it right there switch from decreasing to increasing? So again, some people like to make the graphs, the derivative and the second derivative, and kind of answer the questions that way. Some people like to just look at the original and think about slope and concatenate. F double prime of x is switching from what to what? What's the second derivative over here? Negative. Why? Because the original graph is concave down. And then we switch to the second derivative is positive because the original graph is concave up. Look at our second derivative graph. It's this line here, this diagonal line. Isn't that graph negative below the axis up until this point and positive after? So f prime of x is switching from negative to positive. Better it is. How's this going? Like, give me like, this is easy, I love it, totally fine. I don't have a clue what you've said for the last hour. Kind of in the middle. Jasper, no thumbs? Jasper gonna flip you out. Okay. So try the, I apologize, it's like on the back. I know it's kind of annoying to flip back and forth, but I want you to do zone the back of that first part. So we'll do the second graph and the third graph tomorrow. This part here is your homework. So I mean, I'd want you to do it right now. I'll do it right now too and get answers so you can check. Way more time left than I thought. This is not homework. The next one's going to be homework. Do this now and we'll check it. Should I put the answers up or not yet?
Not yet.
You don't have to love. You just want to check them.
This one, why is it after you had increasing to decreasing, or decreasing to increasing? Why is it that you can try the bugs? Yeah.
Zone B to zone C.
Yeah.
Well, it's a different type of point. And this one is the relative back. You're talking about like a derivative model, right?
Yeah.
Okay, so my derivative was positive prior to that. And negative after, just means it's going up.
Yeah.
With the concavity switch, like your derivative's negative that whole time. It's going to switch from B to C. It's the decrease to increase part. It was your slope was negative and getting more negative before that than it changes to negative and getting less. So that's when it's
function that's when you would use instead of saying positive, negative, you would say increasing to decreasing.
or decreasing.
Okay.
Here's the answers. So you can. I think it's probably useless if you don't know if you're doing it right or not. You know. Okay, where what? That's not a question. You cannot attack that. So I need a specific sort of thing. So where are you? What brought you to right now? Just F or F? Okay, so let's see. So is the original F is the original graph? What do we know about the original? No, it's negative. Well, the x. No,
Should it be axis?
for the original? Yeah. Part of the issue. So in that spot, we know that flex is negative. We know flex is decreasing because we can see it. So we know flex is kind of getting up.
I get that one.
Okay.
I guess I just took this last one when you're saying that. Like, I keep thinking it's the opposite. So like this one. I don't know.
So here our slope is negative. You can see it.
Yeah.
But it's also decreasing because it's getting like more extreme negative.
Oh, okay. Okay, I guess I just like, I don't know. That makes more sense, I guess.
So try to get a look at the answers and see
Okay.
what's specific.
Yeah.
We're just like bouncing around.
Yeah. Okay.
Which is like, I'm not opposed to that. It's just more hard, you know what I mean? More efficient. So what I want you to do right now is just this. We'll come back together in like 2-3 minutes, and I'll go through them and take questions. But then the next graph, there's 2 more graphs. The next one graph I want you to do for homework. So like if you're done with this and you want to move on, go ahead. How many are done with this and have them right? Like how many feel good about the ones you did? Okay, that's cool. Paige, you look like you're about to ask something. Nope. Are there any questions right now I can answer on this? Like why is this one this? Why is this one here? I thought this was something different. Okay. So do that next one for homework. It's the parabola. That's all I want you to do. It's like a point of inflection where it switches. So basically the graphs are just connected using ends. So, you know, down, switch, and then be up, switch, down, switch, up, switch. So down. You should have raised your hand twice. 2 hands. Yeah. So where's the one you thought was true? That is negative. Very good. We are okay. So that's true though. The original graph is decreasing. Your slope is also decreasing. Your slope is because you're curving down, so your slope is getting more negative as you go. So that's decreasing. slope itself here is positive. Because at the very beginning you got a steep slope, a steep circle. It's flat. Yeah, well, I would say you wouldn't do it that way. That's why I don't want you to do that one today. I want you to do it tomorrow, so you have more time to forget. The problem is if I start doing like three wiggles, like a fourth thing, I got like 7 zones, and it just gets like harder to talk about. But don't do it that way. Like still process it. This is really crazy.
I don't know. I'm very visual.
Yeah, this is like
if I get a lecture with written notes, I can learn something on heartbeat. But if I'm just told, okay, this is the process, go figure it out, or like trying to physics in and I'm trying to imagine a plane and a fly and hit it, it doesn't work too well. But
some people love this stuff. Great.
Literally, like, everything else I just don't know is using
We got more time.
everything else I picked up like really quickly though.
see, and I mentioned this in the opposite, like it's in asymptotes high from the outside wall. They're
But
like
this-
safer. But
This
this
is
is
like, I can tell you were in the first one right away.
and when you were doing the zone B stuff, I had most of it written down before you got so the stuff is happening really well.
Right? The good news for you is that AP Calc loves questions. Loves. Bad news for you is that AP Calc loves questions. You'll get it. It'll just take time.
Yeah. If I get the first level right, then I can
Then you can keep going.
Then I can just see, oh, it's concave up, so it's increasing in positive, so I can see that.
Right.
That's how I
I
can
just
go.
like it takes me like a good bit to just like
Say that again.
down.
Once you get the first, what?
Once I get the first like 3 like decreasing up, I can see the decreasing means the second or the first derivative is negative.
Gotcha.
Up, so the first derivative is increasing and the second one is positive.
Okay.
I'm not sure I can go backwards, but I can go that way.
It's with a graph, with extra information, I can go backwards. But
Well, that's the next thing. Actually, is I give you a graph of the derivative. I'd ask you all these questions, basically. So we start at a different level.
well, okay, but if you have a graph, then you can tell where f(x) is positive or negative, and then if you have
Just where it's increasing or decreasing. Because the derivative graph tells us the slope of the original,
Oh
right?
yeah.
So we can't, like, I might be able to make a shape, but I don't.
Okay, I misunderstood you.
Okay.
So then you have to take the integral of the graph to figure out where it's positive or negative
Yes.
for very first shot.
But they usually don't care about that. They care about the shape. So let's say, like, where's the original graph increasing? For example.
Yeah.
Yeah.
So is this when we switch? This is it this positive Because it's concave up.
It's just concave up this whole time. It's
So
concave up in
it-
this zone and in this zone.
Right.
So.
So that just means it's positive. Okay.
So these are okay? Like, everybody's pretty solid here, you think? Okay. Laura, we'll check that next one. We'll keep going and then look at things like different ways. Keep track of them.